a little bit more time to break for dinner, before dinner. George is going to be talking about use of threads in his Peloton package. And then me, I'll be talking basically about things you can do with email and Tickle. Tickle Builder is only part of it. And Andreas will be speaking about Crimp.
Okay, so it's me again, and I'm going to speak about my application called Elogon, and the challenge of threads, actually not the usage of threads as Cliff said, but rather the ability to use threads because of some design, perhaps wrong design I did in the past. So I'm going to say a few words about the Elogon NLP platform. Its architecture and data model, like collection documents, attributes, and annotations. Something I call the object cache. Thread safety and multiple threads inside Elogon, and finally my conclusions. So probably not the first time you are hearing it in this conference, but Elogon is an infrastructure that allows you to do natural language processing. What is natural language processing? Natural language is the language we every day use for communicating, like English, Greek, French, Korean, Japanese, Chinese. This is natural language. And natural language processing means processing texts in these languages in order to do interesting stuff like summarizing a document or extracting information from a document. As a platform, it does not do any processing by itself, but actually provides the needed infrastructure to developers to perform natural language processing, and offers you the infrastructure for managing corpora. Corpora are collections of documents, nothing more, or to manually annotate corpora, and of course for loading processing components that can do these useful operations on corpora. Okay, some details about the application. It's quite an old application, started in 1998, still in use, but a lot of legacy code. And it was among the first platforms to offer multilingual support, that means Unicode, of course, because it was based in Tickle 8.1 that had a very good support of Unicode. The first prototype was written entirely in TickleDK. The performance was not good, but the memory consumption was excellent. It was using much less memory than other applications. And actually, the motivation behind developing Elogon was because we were using at that time another platform, and we had the components, the processing ones, but we could not complete an experiment because the memory consumption worked up to 2 gigabytes, and the application simply crashed after that. So just a simple prototype in TickleDK that emulated that other platform did the experiment. Okay, took more time, but we had the results. So while you are processing a document, actually, okay, I'm missing a slide here. The decision that I have made is to base the Elogon data model in TCL objects. So the way I store internal information is stored in the form of TCL objects, and processing a single document actually results in a lot of TCL objects being created during the processing. A typical number of TCL objects is around in the thousands. And what we have seen by observing what we keep in memory is okay, that objects tend to contain the same information. So the simple idea was we want to cut further memory consumption. Why just build a cache of objects? So we can have a cache, we can reuse objects as appropriate, and since a lot of them contain the same information, it will be a save in memory. TCL objects allow reusing, they have the reference counting. So we have implemented it, and yes, it was good. the solution worked well for many years, and actually it's one of the applications that use the fewer memory to perform the same tasks. But nowadays we're facing another problem because recent hardware introduced multiple processing cores, and we're keen to using multiple threads into the application, but the big question is how our data model can play with multiple threads. So you have seen this before, it's the Eloquent architecture. There is a core in C++, and in C there are the processing components, there is a graphical user interface, some services that are floating around, interaction with the operating system, and serialization support. Now, how the data model is defined? The central piece of our data model is the collection. What is the collection? The collection is simply a set of documents. We can store information in the collection itself in the form of attributes. What are attributes? Actually, there are named values that have a type. For example, I can define an attribute in the collection called language that has a value of type string and has a word Greek in there. The document is something similar. It has a textual data, that is the text of the document itself, but also has information about this data, the linguistic information. The linguistic information is again expressed in the form of attributes, which are the same attributes as the collection one and affect the whole document. An attribute refers to the document as a whole, but also more localized information in what we call annotations, which actually associate a set of attributes with specific portions of the text. Any questions? Okay. And here is the anatomy of a notation. You can see a simple sentence. Everything is counted with a character in character distances from the beginning of the document, which has the value 0. And below you can see how some annotations can be seen in a widget. And we can look closer to the annotation. It's actually a list of 4 things. There is an identifier that identifies an annotation unique in this document. There is a type. Okay, there is a type that classifies annotations into the categories. There is a set of spans that are start and offsets that can associate the attribute set with offsets in the document. And finally, there is the attribute set that contains the linguistic information. Actually, all this is a standard called, this modeling called Tipster, which was the result of a project funded by DARPA in the late 90s, the US DARPA. So how we have implemented things? What is a collection? A collection is actually a C structure that, among other things, keeps this information. A list object, a TCL list object, which contains the documents to be deleted, if any. A TCL command token that represents this collection at the TCL level. A TCL hash table that stores the attributes of the collections. And, okay, 2 TCL objects that can hold arbitrary information. The document is a similar C structure that contains similar information, again a command token, again a hash table for attributes, but it has also hash tables for annotations. Annotations and attributes have been implemented as TCL objects. The attribute is a plain TCL list object that has 3 elements: the attribute name, the type of the attribute value, and the value itself. All of these are TCL objects. And the annotation, it's also a TCL object, but okay, of custom type, just to save up some space, but actually can be converted again to a TCL list object. It has an annotation ID, which is an integer, the annotation type, which is a TCL object in name, a list of spans, where each span is again a list object with 2 elements, and a list of attributes. And now we come to the object cache. Actually, this is what I said to the beginning. We have implemented the global memory cache for TCL objects so as to reuse as much objects as possible. And this cache contains objects from all open documents and from all open collections. The usage of a cache is when a new item element is created, such as an attribute, a span, or an annotation, when a processing component adds information to a document, or when a document or a collection is read from the disk. Why the cache is important? Because linguistic information when processing a document tends to repeat a lot. For example, imagine that you have a document that contains 10,000 words and that you want to apply a part-of-speech tagger on it. A part-of-speech tagger, do you know what part-of-speech are? It's just this word is a verb, this is a noun, this is an article. So if I apply a part-of-speech tagger on that and create just a single attribute, that means I need to create 10,000 token annotations. That means 10,000 objects, which of course contain 10,000 part-of-speech attributes, which again contain 10,000 values. And if I assume that the tags set, the available tags, the values of these pose attributes are only 10, each value has a possible repetition in the thousands. So if I use something to not create every time a new token or a new pose TCL object and reusing an old one, of course makes sense. And if I am able to cache even larger constructs, makes even more sense. And if I share this information across multiple documents, makes even greater sense, because the more documents you add into the memory, actually the fewer is the increase in the memory used by all these documents. Any questions? But there is a disadvantage to this. The object cache is spread unfriendly, because a TCL object cannot be shared across multiple threads. On the other hand, right now, the parallel processing of documents inside the platform is a highly desired feature. But the thread safety of doing so, it's an open question for me inside Elogon and in the way I have done things up to now. The core component of Elogon, which is called the CDM, the Collection Document Manager, that implements this data model and the object cache, is already thread safe as an extension. That means the global variables are few and the access is protected already by mutexes. The object cache is global, again is protected by mutexes, all access to it. And all Elogon plugins components use thread-specific storage for storing what they think are global variables through special proportional definitions, for example, for C++ components. But Elogon as a library is a thread-safe extension does not mean that inside the library I can use threads. For example, you can see here Elogon running under Linux as a library. There is a C++ application that starts 2 threads, and an instance of Elogon is loaded in one of these threads. So in a single application, you can start multiple instances of Elogon. And this works even if there is Java involved, because one of the languages supported by Elogon is Java through TCL Blend. I don't know how the author of TCL Blend managed this to work, but it does. You can see here, I've run in both instances the Hello World module, and that just prints Hello World, and you got the result into the application without crashing. But this doesn't mean that inside a single Elogon instance I can use threads. So can Elogon become multi-threaded? I don't have an answer to this, and I think that it's difficult to be answered. But I know what my requirements are. I need the graphical user interface to not block during component execution. Okay, I have workarounds like putting progress bar and components, updating their status, but actually nobody uses them. So actually when you run a component, it blocks. Which suggests that probably it should be running in its own thread. And of course its execution chain must run in its own threads. Ideally, what I want is the documents of a collection to be distributed to n threads and run in parallel. This is a highly desired feature. But there are obstacles now formatting two threads occasionally. The first main obstacle is the object cache. Of course, it's a global cache of TCL objects. One idea is to split the object cache into multiple threads, but I expect the memory usage to be increased, and I'm not sure that I want that. And another obstacle is that the GUI is in decay, and it's not only the GUI, it's also the viewer for the linguistic information. So you have done your processing, you want to see the results, you just open up a decay window where the results is in there. When I was designing Elogon, using TCL objects was a good idea because no conversion was involved. I could display very easily TCL object in a decay GUI. But if I decide to run the GUI in a separate thread of its own, I may be in the situation that whatever thread I create the TCL object, I need to deep copy them in order to be shown in this decay GUI. And then there are the plugin components that are written in TCL, which tend to overcome the API and just use data that should be accessed through the API as TCL lists, because they know that actually there are TCL lists. So instead of doing a loop with the API proposed by the tipster standards, they apply for it on the annotation, so it gets converted to a list. And I cannot blame them, it's easier to do that. So, conclusions. Okay, Elogon has been in active development and used for more than a decade now. But nowadays, enhancements are required in order to exploit better multi-core processors. I'm in the point where I don't know how to introduce them. It is unclear for me whether I can introduce threads without the major reorganization of my platform and without breaking compatibility with existing components. So anybody who has any idea, I'm very glad to hear. So that was it. Thank you. Not actually a solution to a problem, but a paper about the problem. Sorry for that. Thank you.
Don't need to ask if this thing is on. Rack. So, a few moments before my machine is quite ready to go. What I'm going to talk about is dealing with email, and mostly fairly crude methods of dealing with email, because most of the email I get is fairly crude. Yeah, thank you.
Can you tell me that list you're subscribing to get that?
I didn't really subscribe to the list, but it kind of arrives.
Yeah. That's the line that comes right before it. I just flew in from LA and boy, my arm's tired. Anyhow, my site is small. I have a very small server talking through, God help me, a 28.8 modem. And I still get 20,000 email deliveries a day attempted. Of those, I still see about 2,000 that are actually legit. And there's probably 500 or so a day that I actually want to pay some attention to. Shame I don't know my name. over the years, this has meant that I've done a lot of ad hoc things to solve whatever problem I had right now. And it solved the problem, so I've never stopped doing it. And every so often, I'll go back and clean things up and do it a little bit better than I did last time. So, talk about handling email. I think everybody knows who I am. So this is just a graph that I pulled off of email traffic for a roughly 20-day period. You can't read the numbers, but that's 20,000 number of emails that tried to come into my system. And down here is the number that actually made it in, which is in the 2,000, 1,000 range. So, kind of mail that you get. You get stuff from coworkers and clients. You get a fair amount of that, and that's important. You don't want to lose it, you do want to see it. I get mail from new clients. That's a fairly small amount, but it's really important. I get mail from my friends and my relatives. It's a reasonable amount, and if I don't answer my mother, I'll get a phone call. The mail from the mailing lists, there's a fair amount of that, and it's got value, so I don't want to lose it. And then there's the mail from the spam box, and there's an awful lot of that. And I want to make sure that I kick it out of the way, but I don't want to kick it so far that I can't go back and check and say, oh, this thing that looked like spam really was an announcement from my bank that they're changing my security code. It's a bank that I actually do business with. So, when this first started to be a problem, the first thing I said was, Tcl is good for parsing text. Email is text. Therefore, Tcl is good for parsing email. QED, ipso facto. And that led me to the next step, which is email arrives at random intervals. File locking for these things is actually a little bit tricky. The guys who did ProcMail got it wrong several times. The existing email applications have already solved this problem. I don't really need to. And expect can control a text-based email application, and therefore expect can run around. No, that's not right. Therefore, email can expect to be locked. No, sorry. Therefore, I can expect to be a little tricky. What I ended up doing as a very quick, I need to just be able to read these emails, do some sort of quick sorting, and put them into separate bins, was I use expect to run the crudest and oldest Unix mail application. It runs mail. And it sends the 1, the 2, and the Q, and the W, and all those things that you used back when you had a 1200 baud modem, or a 300 baud modem. And that's really nice. It sorts my mail into the appropriate bins, so the mailing list stuff is all in the mailing list bin, sorted by different mailing lists. My letters from my mom goes into one labeled priority. Same with my wife. Her mail goes into priority. That's why I'm still married. And things like that. And that just makes life a whole lot easier than trying to look down through that long list of emails. And nobody ever sorts them the way I want to. And with this I can. So have a separate file for each piece of email. Each file is an MBOX format, just a standard Unix format, so I can run any mail reader to read it. It gets read with expect calls mail to read things in. Just plain old put S to put it out. And then I've got my sorting application. We've had talks before. Tcl is just really nice for writing a domain-specific language. So I've got, you use a proc, it just fits in with Tcl, but now you've got commands that really look like what you want to do. So I've got a proc here. It's called first and save. I give it a substring, the data that I've got and where it might want to go if it matches that. And it just does a simple string first to see whether or not this pattern is in there. And if it matches it, it puts it where it belongs. And then I've got a meta file of the information. I've got all the actions, what part of the header to look at. And if you see Tcl Webmaster, it goes into the Tcl Web. It's worms and this came from worms and was sent by this mailing list. It goes into the worms. If I don't have something really specific that goes in there, I can always throw in a Tcl string to do my comparison and then save or to something else. So when registration forms come in, they just get passed off to the registration processor. For legitimate emails, that works pretty nice because I can go through and I can take a look at a piece of email that I know I want to deal with and say, okay, this one uses a from to distinguish that it's from the mailing list. This one uses sender. Different mailing lists use different conventions. getting the spam out of those bins is a little bit trickier. Hard rules are just plain hard. Trying to come up with rules that will catch spam. Even if you do, look for bad words. You don't want anything that has the word money in it, or inheritance, or sexual enhancements. You can never tell when somebody is going to send me a legitimate email with all of those words in it. Yeah.
You don't understand.
This is a true story. In the 1600s, there was an Irish philosopher who wanted, he was an Irish clergyman, who wanted to meet a reclusive English millionaire. And he couldn't get in because the guy didn't talk to Irishmen, for one thing. He was a recluse. And what he did was he sent the Englishman a letter that said, "Dear Mr. Jones, I have recently returned from India, where a gentleman with your last name had died. You may be entitled to an inheritance. Would you like to meet?" Just a little 400 years ago. It's still going on. Everybody's familiar with doing the Bayesian stuff. That became pretty popular about 6 or 8 years ago. And it works. And all we're doing here is text stuff. We're looking at text. Pickle is good for doing stuff with text. So, for people that aren't real familiar with the Bayesian spam detection algorithm, which is like most of us, the basic idea is you train the filter by giving it collections that you know are good and you know are bad. So I had to go through and actually sort out my spam and save it for a couple of months. Unfortunately, it didn't take that long to collect enough. Build up a word frequency table between what's on your good word, what words come out in your good mail, and what words come out in your bad mail. The spam hardly ever has words like bitrate in it. The good mail has those things a lot. And being a geek, the good mail hardly ever has sex in it, but the bad mail does. So converted those tables into associative arrays with the word as my index, and the value is the likelihood of this thing being in a spam. And then each email gets assigned to a score. You just go through the email, split it on words, and take things out. This actually worked fairly well. The problem is that starting up the Bayesian filter was really slow. That word table is about 1.5 megabytes, about 80,000 words. So what I ended up doing was turning it into a daemon, and the rest of my programs just call it up when they need to and send it off email to be analyzed. And as we all know, client-server in particular is so simple. We just use it without thinking about it. Doing some work with some guys that use PHP, and I said, well, we should just open a client-server socket between our applications and just talk. Yeah, what, did I say something? Okay. That was really nice. I pushed stuff into the separate files. I decided I wanted a little bit more, and all of the email goes into a file with its own name in a folder, and it was pretty easy to build something that was just a button bar. It's just a loop. It says for each glob file name, build a button that does an exec to open a command name, an extern with mutt running in it. And so I just, and then it does an after event every so often to go off and see if there's any new mail and highlights that button red. So I can just glance at it, and it does what I need. I click the button and read my mail. Downside is that I like mutt because Elm isn't being maintained anymore. But you can't read HTML mail inside of mutt. It's just strictly a text renderer. It does support the mail path, so you can put things out in another application if you want. And what a lot of people do is they'll say, if I get HTML mail, kick off Conqueror or Firefox or something like that. Problem is that web browsers are designed to really pull everything in that they need. And the guys who write spam mail know this. So you get things, that funny long image name is your address encoded in there, so they know that when that web browser goes, you're a legitimate address, and you're probably worth $0.015 instead of just $0.005 on the open market. So what I did is I wrote a little thing called HTML view. Originally I used the TK-HTML package of Stephen Euler's, and then took Richard Kipp's widget and used that. This is the one thing that I'm talking about that actually is available in the outside world. I forgot to bring up the web browser. unfortunately, most of the stuff that I've done for me, and I've done it fast, and I've done it dirty. And it's got hard-coded pads and other things in it. And isn't real happy going out. So when it comes up, it lets you see your email just like it is, but it's stupid. It does not know how to resolve any kind of a link. It can't display an image. It can't run JavaScript. The one thing that I did add to it, because I really need occasionally to check and see whether or not this PayPal notification really is from PayPal, is you click examine, and it highlights all of the HTML stuff, and hrefs get highlighted in green. So I can just scan through it real quick and say, okay, this thing from the Abbey National Bank is my online account to abbeynational.co.uk.oe3something-or-other.com. I'm pretty sure Abbey's Bank doesn't have the rest of that stuff after the UK. So that gives me a nice safe way to read the mail that is otherwise not safe to read. So like I said, spam, 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 spam. 20,000 people hit this site. 500 to 1,000 are what I'm actually willing to let in. I can filter those things off using my mail filter and things like that. It's a whole lot better to filter them off at the door and stop them from just coming in. This second little column here is the number that my filters rejected without even letting them in the door. So yeah, I'm happy to get rid of that much crap.